Hello, everyone. Welcome to the next Bevy Meetup. This is already our fifth installment, and I'm super happy to have you all here. This time I'm reporting live from Thailand, and I hope that my connection stays stable. But it's not going to be my connection who has to be this most stable, because we have two wonderful speakers today. Let me quickly put up my introductory slides so we can go through the typical introduction part. Yeah, this is the Bevy Game Development Meetup. Today is going to be actually not purely about game development anymore, and I'm super excited for you guys and myself to see a little bit more insight how Bevy can use in other areas as well. We have two amazing speakers today. We're going to have the same format as previously, 15 to 20 minutes each, 5-minute Q&A. We will probably not be able to do a panel discussion today. Sorry for that, but there's going to be the typical Q&A part. Please scan the QR code or use the link in the description for the live ask page to post your questions and vote on questions from other people so that we can make sure to address what's most important to everyone first. And I think we will have enough time still, as we are just two speakers today, to address any question that comes up. Yeah, code of conduct, just as a reminder, be kind, be respectful, be curious, and reach out to me if you have any concerns, if you have any observations that you want to share. You know how to reach me. Who am I? I'm Stefan. I'm already hosting this quite some times, but if you're first time today, I'm working with Rust since 2017. I've spent almost 17 years in the games industry. Two of my major open source projects are Git UI and LiveAsk. And I recently founded the company Rust Unit, which is also sponsoring this format today. And now, another time, the big QR code for the Live Ask Q&A page. Scan it here or use the link in the description. And without much further ado, I will pull our first speaker on stage. Florian, I'm super excited to have you here today. We met in, it's already been 2 months almost at Oxidize, and I was super excited to see Bevy in a very non-game development space. And you're gonna tell us more about that today, right? I'm gonna pull up your slides. So take it away, Florian.
Thank you very much, Stefan. I actually thought that it was 1 month ago, but time flies by very quickly, obviously. Yeah, so hi, my name is Florian. I'm with Electrobit now for almost 20 years. It's basically most of my working life. In very different positions, but always very development related. And today I would like to show you something which we created last year, which was kind of an experiment at first. And then it turned out to be a quite nice thing to show at exhibitions and like at the Oxidize conference. Okay, maybe to give you some idea what Electrobit is, because I think it's not the most known company in the world. We are a company which creates software for cars. We are working together with a lot of different car manufacturers. Yeah, not completely limited to automotive, but mostly we are doing automotive and mostly we are doing software. We have offices in a lot of countries in the world, 4,000 employees. What I find very interesting is that we have software running in 600 million cars worldwide and 5 billion embedded devices. And maybe you're asking yourself, how does this fit together? We are in automotive and we have so many more embedded devices compared to cars. The reason is quite simple. Each car has a lot of control units like airbag controller, engine control, braking, and so on. And if you count all of them together, you get a quite huge number. We have a lot of different products. I'm not going through all of them right now. Maybe just to highlight two of them. One is EB-Corbos, which is our own Linux distribution. I hope that one day I will be able to show some Bevy application on this Linux version, which is based on Ubuntu, by the way. And we also have EB-Trazos, which is an operating system for very, very small control units. Like if you have just a few kilobytes of RAM for airbag control, for example, where you have very strict functional safety requirements and also timing requirements, then this is a nice product. And we are also creating so-called cockpit solutions. And yeah, this is something where we are also very proud of. This is the cockpit from the Sony Honda mobility car. The car is called Afila. And yeah, basically the whole display that you're seeing there is coming from Electrobit. Also, the kind of computer which generates all the image data is coming from Electrobit. We are using a Qualcomm processor for that, which has 8 CPUs and 12 gigabytes of RAM. And on this device, we have 2 operating systems running at the same time using a hypervisor. One of them is Android for the right-hand part. Infotainment is often done today using Android. And on the left-hand side, behind the steering wheel, you have the instrument cluster, a modern instrument cluster just consisting out of one display. One thing I would like to note there is that the image of the car in the cluster instrument, that's not just an image. It's actually rendered in 3D, and it can rotate depending on the situation. For example, if you open a door, the real door of the real car, then this is reflected in this 3D image. So you can see how the model opens the door, and then it rotates into a situation where you can clearly see what is going on, which door is open. And I think also some lights like indicator are synchronized between the real car and the 3D car, which is rendered there. And this is something which was very impressive for me. It was done using a commercial gaming engine, which maybe starts to explain why we are using or experimenting with Bevy, which is of course written in C++. And I was very interested about Rust. I started becoming interested about Rust something like 3 or 4 years ago. And whenever I wanted to talk projects into using Rust, then one of the questions which came up early were always, does Rust support QNX? And back then, we did not have, or Rust did not have QNX support. So this is something I have added last year together with BlackBerry. BlackBerry is the owner of the QNX operating system. QNX is, by the way, an operating system which is also a real-time operating system, which is used very often in the automotive industry. As soon as you're having bigger systems like infotainment systems, then QNX is used quite often. So I added that. But still, it was not so simple to convince our risk-fearing people, customers were afraid to test or to use this because we only had very small test application. I mean, we had something like 20,000 test applications from the Rust standard library, but nothing bigger, something which is more impressive, where everyone understands, okay, this is something serious, we can really use this in a product. And yeah, so last year we talked about that, and then I had the lucky situation that one colleague of mine who implemented a lot of instrument clusters in the past had a few weeks of free time between two projects, and he wanted to learn something new. And he already had something like 2 weeks of Rust experience. Experience meaning he read the book, and he did some Rustlings exercises for a few days. And I was able to convince him to give this a try. And I read about Bevy, which is quite, as you know, very popular in the Rust community. Yeah, and then he started watching YouTube videos, how to use Bevy, what is an ECS. And within a very short time, which was, I think, 5 weeks, he was able to implement a not completely full-featured, but a very nice instrument cluster software, which has typical items that you can see there, which is interactive, which I was then showing at the Oxidize Conf, also other exhibitions, what you can see here. So the basic layout of this demonstrator is basically the same as you can see in the Afila car. We have Android on the right-hand side. We have QNX with a cluster instrument on the left-hand side, which is usually behind the steering wheel. Yeah, and it has almost the same hardware. Also, a lot of the software stack is the same, with the main difference that the cluster instrument is written in Rust using Bevy. And yeah, it's not so easy to, or not so nice to see it on this photo. So I'm now going to show you this live. So let's stop the presentation and pray to the demo gods that everything works fine. Okay. I hope that you can see this window now, but it looks good. So this is the cluster instrument, which is a little bit advanced to what we have done last summer, and I can control it a little bit with my keyboard. So if you hear me clicking, then this is when I remote control it. We have some startup animation with logos, and this build-up animation of the tube in the middle. I can pause it to show some aspects, like we have this trip info tile on the left and some infomercial slides on the right, which was nice for demonstration purposes when someone is just walking by at an exhibition, so that they get some additional information. But basically, we can do a lot of things here. We can enable telltales, for example. I can change the speed. The blue gradient, by the way, is created by a special shader that we have written, which was really fun to use, because of the file watching feature in Bevy. We found out that it is extremely nice that you can change some shader code, press Ctrl+S to save it in any editor, and immediately, without having to restart the application, to immediately see the effect. That was really, really great and fun to use. Okay, so this is something we have shown at the Embedded World in Germany, for example, in April. but still there was kind of the impression that this is just some video which is playing in a loop over and over, and after some time it simulates a shutdown and it starts again. But the overall impression was that this is like a video. And we wanted to change that. So what we created then for the Oxidize Conf is another application, again created in Bevy, which is running on Android. And we can then use this to remote control our application. Yeah, and it's working. So for example, I can pause the video and switch on some telltales and add a media status, which you can see there. It's now just dummy data because usually this data comes from the Android system. And if you play back something there, then we get the actual title, subtitle, and also a small picture cover image from the video or from the song that is being played back. Okay, so these are the two applications that we created, which are very truck specific. This is one HMI concept that was once created at Electrobit to do some experiments. Yeah, so one thing which I was asked often and which was also not clear to me at the very beginning was how to bring car data into the application. I think you all know how to model such applications like the instrument cluster, but how do I get actual car data into it? And for this, we had a very simple module created, which just reads strings from standard in, line by line. Then we are using 30 to pass the string into an enum value that we are sending via a crossbeam channel. And then on Bevy side, we have a very simple system which polls the crossbeam channel for some events, maps it into more specific Bevy events, and then just sends them there. So for example, if I get an event to pause the simulation, then I would send something to our or send a state event. And a media event, for example, is then sent to a different event, so that our correct module can process it. Okay, so let's go back to my presentation, which is almost done. Yeah, so this is what I was showing there, which was great. There is one thing that is a bit unfortunate, which is we did not get 3D running at all on the device. I experimented a lot with different conditional compilation switches that I found in the source code. And with those switches, I was able to bring the shader compiler into a state that it would accept my code at the beginning, that it does not complain about missing shader features, but it always failed compiling them. So if there is someone in the round who would like to do some live coding one day to bring at least a very simple scene running or starting. At the moment, it's just sufficient to have a 3D camera spawned, nothing else, and it would just panic at startup. That would be great. If you want, then please let me know. and then maybe we can improve that. Yeah, and then I would go for the conclusion. It was very fun to do that. We learned that using Bevy is very simple, even if you do not have a very deep Rust knowledge. And I think part of that comes from the ECS, which kind of fixes or works around borrow checking issues. We almost had none of them, if at all. That was really great. One thing where I was really impressed is that the person who did the first implementation in those 5 weeks, he has a lot of experience with very different tools, like different HTML5 frameworks, Qt, Kanzi, which is a no-code solution often used in automotive. Also, he has a lot of experience with some in-house tooling that we had at Electrobit. And he told me that using any of those other tools, even though he has much more experience with those, would not be much quicker or easier or more productive compared to Rust and Bevy, even though he basically had no Rust experience and no Bevy experience. And still he would be as productive, or roundabout as productive. This was very impressive for me. So to us, it was a very successful experiment. I'm not sure whether I would use the framework today for a productive use. But if you want to have something nice running in a very short time, then I would definitely at least take it into consideration. Okay, that was all from my side. I have some frequently asked questions prepared, but I would like to hear from you first, if you do have questions.
Thank you, Florian. Amazing presentation. I think everyone was excited to see Bevy in such a unusual environment. Yeah, we got some questions. I'm curious to see if those overlap with the frequently asked ones that you are used to. But yeah, let me read out the top voted one so far. Is the control UI running on Android with Bevy too? I think you mentioned that it does, right?
Yes,
and so
yes.
the follow-up is, how difficult was it to make a Bevy program run on Android? And thanks for the great demo.
You're welcome. Android was actually quite simple. Why can't I change to the right slide? 1 second. That one. Okay. So we have Android on the right-hand side, and yes, this is also an Android application. And there is a package called Cargo APK. And with this, as far as I remember, we didn't have much issues. It was quite straightforward.
Yeah.
And we can easily sideload there because it's a system. The whole Android stack is coming from Electrobit. So it was pretty simple to get something running there.
Nice. Okay. Yeah, you mentioned that in this screenshot, in the very beginning of the presentation, the car was rendered in the usual game engine that you just mentioned. And the question is, which one is that? Like, which is usually used in cars for that sort of purpose?
I don't know if it is usually used, but I do know that Unreal is used in some cars. Or at least there are experiments with it. I'm not sure if it is in a serious car, but I have seen it in demonstrators.
Okay, interesting. Next one. Does that mean you run Rust on these billions of embedded systems? I think we heard that Bevy is not in production, but how about Rust in general?
Rust in general.
Like, is there any car that runs
The
with
Sony
Rust
Afila
code?
car. This one definitely will have parts of the cluster instrument rendered in Rust, not using Bevy, but rendered in Rust. The reason for this is quite simple. Well, there are two reasons. One is if you are standing next to the car, open it, sit down, then you want to start driving, and this takes something like 1 or 2 seconds. And we can start up QNX in this time, and also start up a small Rust application in this time frame. But you cannot boot Android, for example, which is why it needs to be running on QNX. And this is one of the first cars where we are deploying Rust code, at least on QNX side. In our EB Corpus Linux, we also have 1 or 2 applications which are written in Rust, which are also open sourced. But I don't know whether they are in serious cars or not. Okay. We are having different projects and products where we are starting using Rust.
Yeah. The next one is personally interesting to me as well, as I'm a victim of the Bevy UI myself. So the question is it Bevy, vanilla Bevy UI that you're using there? If not, yes. What else? Or is it just a dummy?
Well, I can show you all the code if you want. But it's just vanilla Bevy. On QNX side, we have 0.12, I think. We started with 0.9 and then upgraded from time to time. And I even did these 3D experiments with 0.13. But there it was still not running, so we stayed at 0.12. But it's vanilla Bevy. Well, the Bevy code itself is vanilla, but we have some QNX-specific adaptations, I think, in WGPU and WInit that we need for QNX to control, for example, which display our image shall be shown. So okay. This is the only change that we have done.
But the question was specifically about Bevy UI. So these elements, like the coming in of the media player and stuff, this is not fake. This is actual UI elements. Bevy UI elements.
Can I move that there? So everything that you see here is done with just Bevy UI.
Nice.
Well, the thing in the middle, the tube in the middle, is just standard Bevy stuff, like normal entities and images. And the tiles on the right-hand side and the tile on the left-hand side, they are actually UI elements where we are using CSS, for example, to render the table and lay out the table. And the table is also live rendered. It's not just a picture.
Wow. Okay. Yeah, I mean that would be a whole different conversation to look at the code of that. That must be a giant. But yeah, that's pretty impressive.
It's not that much. If we have time left, I can show you this for a minute.
No, I think we have still a bunch of questions, and I know that okay. You are also tight on time today. So I would like to go through the last, probably just one more question, and then we will also answer. So how do these two systems communicate with each other? I'm not sure if you mentioned that, like the Android and the QNX side.
I did not. but I'm happy to show you that. So we have this one thing which is reading from standard in, and we have a very special automotive protocol which is used to communicate with Android. And there was some existing code there that I've used to get media information, but media information only. And we had this existing C++ code base, and I just stripped away everything, changing it so that it creates some simple strings, some simple JSON strings, which look basically like this. This is a script that I'm using to have some randomized activity there as well. We also have a web server there that we are not using to communicate with Android. And so that is for media. And for our control application, which is somehow behind the other thing, that's strange.
That's funny.
So this one communicates via UDP. And yeah, UDP is that simple.
Okay.
In Rust, as you know, we open a socket, read some data, convert it into a string, and after that, everything is the same as with a standard input. We split it into lines, parse it into an event, and send it. So that's basically very, very simple. And for the web server, this was kind of another experiment. I just wanted to see how hard it is to get a web server running on QNX. Probably I'm the first person in the world who tried to do this in Rust. And it was like 1 hour using a tiny HTTP. That was very simple and straightforward. It just worked.
Nice. Okay.
Yeah.
Look, Florian, that was super impressive, and I can't wait for you to eventually tell me which car to buy to really run on Rust and drive on Rust.
Yeah.
So yeah, thank you so much for your presentation, and I'm excited to see what else is coming there in the future.
Me too.
Okay, Florian, I'm gonna put you off stage now because we're gonna take a short break and then go over to our second speaker today. Wow, that was so cool to see. I can't wait to see Bevy running in my infotainment system eventually in some time. That's super exciting. Unfortunately, we couldn't make it through all the questions, but I'm hoping that that Florian will be around in the various social media channels to maybe answer some of them if people are still interested and curious. So the second speaker today is Spencer, and I came across his profile when I researched how to do vector graphics with Bevy. And a lot of people will be probably familiar with the Velo project. And Spencer is a maintainer on the Bevy Velo integration. And so without much further ado, I'm going to pull Spencer on stage now. Here you go. Welcome, Spencer. I'm super excited to get more details on how this actually works and why this is actually even performant, because that's always what I wonder next, right? When it's about how to do vector graphics in a performant way on our current hardware. So Spencer, here are your slides, and take it away.
Thanks, Stefan. So today I'm going to be talking about compute-centric vector graphics, and we're going to be answering that question of why it's performant to render vector graphics. A little bit about me. My name is Spencer Claude Emblo, and I work as a software engineer for Blue Origin. That's an aerospace company founded by Jeff Bezos. Before then, I worked at NASA. And the way I got into Rust was in 2019. I was rendering a thesis on vector graphics at the time. And back in those days, Velo was called Pete GPU. I've stuck with it the entire time. So this is a multi-year kind of passion project on the side. It's not really related to my work, but it's something I've really enjoyed ever since. So we're going to start with just some necessary context to understand what vector graphics are and what Velo is. So there are two competing imaging models, raster graphics and vector graphics. Raster is the traditional graphics model that you would always think of. You have hundreds of rows of pixels encoded in an image, and that has long stayed as the favorite child of GPUs. It's what the graphics processing unit prefers. Vector graphics, on the other hand, are images that are encoded with points, lines, and equations. So it's an implicit encoding. So because of that, there's less data in the file. It often has a much smaller footprint and is better for networking, as well as it's infinitely scalable. So you don't have the same jagged edges that you would get whenever you try and upscale a raster and you see all the pixels. It's infinitesimally precise at any scale. And the image is derived through varyings. Varyings is like your camera scale, the view box, the section of the image you want to actually look at. But in order to derive the final image, you need to do some computation. So we're going to be talking a little bit about what is the naive rendering of vector graphics. If I wanted to actually render an image, and I know that the frame buffer looks like this, where we have two circles, how do I know if this is a blank white image at the end if I was to rasterize this? Is it a blank white image with a black donut, or is it the opposite? Is it a white donut on a black background if I have just two circles encoded in the image? So in vector graphics, you have to solve this problem yourself. And so here are the two side-by-side examples. Is it the left or the right? And if you want to solve this naively, what you could do is you could kind of ray march from the left to the right, and then you could count up the intersections amongst paths that you find. So if I'm going from the left and I'm just marching along and I'm going to count up one intersection right here, I continue to go through and count up a second intersection here. And then at the end, what you'll find is if you keep a sum of all the intersections, kind of like in a prefix sum, you'll find there's no intersections going from left to right at the top. And then the next row, you have 0, and then you hit a path here, and then it's 1 all the way until it hits the second intersection, and then it's 2 until the end of the image. And then in the middle of the image, there's more intersections here, so it goes 0 to 1 to 2 to 3 to 4. And this gives you a mathematical kind of array model of the intersections. And using this prefix sum, you can decide if it's even or odd. And if it's odd, then you can say that that's inside the image. And if it's even, then it's outside of the image or shape. I'm gonna say shape. So henceforth, we know that this is the correct representation of that image. If it was just two circles, it's actually a donut. So that would be just one way to naively think about how could I render, a vector image if it's like an SVG. But if you want to actually scale up this problem, it becomes more complicated. So imagine if we had 100 shapes on the screen, that becomes a lot more difficult to scale up. And if you're doing a lot of that on the CPU, that's going to have implications on the frame rate. It's not going to parallelize easy. And particularly, vector graphics suffer from what's called a locality issue. So if we add just one more circle around the original donut, then we get a completely different image. It would turn into a bullseye or like a target down here in the bottom right. So just by adding one more path, the image could be completely different. So the locality issue is that you need to know every single path in the image really to be able to derive whether or not a pixel is filled or not filled. And the GPU is just not built for this type of computation at all. There's nothing in the traditional GPU architecture that accounts for this. And you could theoretically shoehorn a lot of the computation into the standard pipeline that has existed for decades now, which is like the vertex shader, the geometry shader, rasterization phase, fragment shading. However, that's very hard to do and comes at complexity, and it would be extremely hard to maintain, probably, since you're trying to solve a problem in a space that doesn't that has a lot of battle against you. So Velo is a vector graphics renderer that has been kind of championed by Google for a few years as a compute-centric vector graphics renderer. And by compute-centric, what we really mean is that we're using compute shaders, which are programs that can do arbitrary compute on the GPU, to directly process the vector graphics. And why you may not have heard of that really until recently is that compute kernels in the underlying hardware has been relatively inaccessible or non-existent before about 2015. In about 2015 and so forth, the hardware access to compute kernels and actually being able to use them has become more accessible over time for things like AI and CUDA and other applications. And now it's starting to really be easier to do on the software side. So WebGL, for example, has no notion of compute shaders. You cannot use compute shaders in like WebGL. Now, with the new emerging web GPU spec that is evolving and becoming more stable in browsers, you're able to actually use compute shaders. So there's been multiple points of friction where we have hardware access and then software access as well. But Velo has become a technology that you can directly process the vector graphics using compute shaders and then provide an API to developers. And it's a very feature-rich SVG-like API for drawing vector graphics. So your standard fills, strokes, gradients, text, images, and when I say images, you can also embed raster images using Velo, as well as like clips and blends and various other rich styling. All that's available in Velo. And I think where Velo really shines is that it's suitable for highly dynamic scenes as well. It doesn't rely on pre-computation. So a famous example of this would be Valve really pioneered the signed distance fields. So if you ever look up SDFs, you'll typically find a Team Fortress 2 image of text being rendered with signed distance fields. That would be an example of pre-computation. As well as there's no performance landmines with Velo. You should see a linear trend of how many curves am I really rendering here? And the linear trend would be the more curves, the lower the frame rate. You're not going to see any cliffs or spikes or exponentiation at all with Velo, unlike your web browser, which is backed by a vector graphics renderer called Skia. So something like the SVGs on your web browser being rendered are being handled by Skia, and it's really optimized for the minimal set and broad case of vector graphics like an SVG on a website. Where it doesn't shine is like heavy PDFs and Google Maps that you might notice those things are not well optimized on web browsers. So I'm happy to say that Velo kind of circumvents a lot of the performance landmines that you might find. And all that is to say, Velo has a very complicated shader pipeline. It's not something I understand at the implementation detail level. This is headed by postdoctoral experts at Google, and it's being funded by Google. So this is just a slide taken directly from Rafe Levian's presentation on Velo. So if you have questions directly about Velo itself, I recommend going to the Linebender Zulip chat and asking the experts that work on Velo directly, and there will be a link to that at the end. What I have developed, however, is Bevy Velo, and what that is it's an integration to use Bevy assets, or sorry, use assets in the Bevy game engine, and we have support for Velo scenes, which is kind of like the raw way to interact with Velo. So we have the ability to render just direct Velo scenes if you want to use the Velo API. We have text support through Parlay, which is all Rust based, so no like Harfbuzz or any C++ tooling in the chain. We also have SVG support through a subcrate called Velo SVG, which directly translates SVGs into Velo scenes. And then we have Lottie animations as well, which is exposed through the Velato runtime. So with Velato, you get both a runtime and the actual translation to Velo scenes. And then in progress, we have .Lottie animations, and Lottie Lab is working on an interactive Lottie format. Lottie is a relatively new thing as well, so don't feel bad if you haven't heard about that. Lottie is a new standard for vector animation formats. It recently became a Linux Foundation open source standard, and it has an action committee around it now. So some use cases just to go over of why you might want to use Bevy Velo. If you want to make video games, if you want to do UI, if you want to make a commercial vector software, so like Figma, if you wanted to recreate Figma, I think that's a ripe opportunity for Bevy Velo, as well as if you wanted to work with vector graphics natively, so like something like a font editor, since fonts are vector and scalable. And also I just wanted to plug a little image attribution here. Cart, the creator of Bevy, he has been experimenting a little bit with Velo, and I thought that was really interesting and integrating that for UI cases. So now I really want to show what Bevy Velo can do now that you've heard so much about it and how it's been used. So I'll start with just the basic Velo demo, but we'll kind of go through the list. So here's actually Velo being run on a web browser. So we see here the GhostScript Tiger. That's kind of like the hello world of vector graphics. We also have various other little tests that you can cycle through. So things like stroke caps and dashing and anything to do with strokes. Strokes are also done completely on the GPU. So no CPU interaction really there. We also have emoji rendering and other things. So here's kind of the even odd fill rule that we showed in the very beginning. We have some various complicated rendering tests just to stress test in some cases, as well as animated and variable width text. And then here's even a raster image that you embed. Now, you'll notice with the raster image, you get those jagged edges if you zoom in, but with vector graphics, that's not going to happen. You'll never see a pixel there. Gradients and other various things. So here's an example of a clip behind a gradient, and blend modes. There's a lot of rich styling opportunity with vector graphics that you just simply can't do with raster. That's really useful. Some of these are just rendering tests and various stress tests. So like this would be a good example of a stress test of just rendering as much stuff as possible. And all this is running on the web browser. Here's a motion mark test, which is a standard test for evaluating vector graphics, and you can kind of go up and down in the amount of paths you want to render. And then yeah, so that's the basic Velo demo. Now this is just using basic WinIt. It's not hooked into Bevy, so that's kind of the difference here. We also have plenty of other demos. So there's a Bevy Velo demo, which this is using this is just one application of Bevy Velo, but we have a Lottie animation here, which has transitions and themes, and it's hooked up to this rich state machine. So if I mouse on, the animation plays. If I mouse off, it goes in reverse. And there's tons of things you can adjust with it too. So I can like stop the state machine. I can play it, lower the speed, go to reverse, lower the speed on that. So now if I play it, now it's gonna go a lot smoother, a lot slower, let go, a lot smoother, a lot slower. As well as you can do things like dynamic color remapping, since Velo is vector graphics are an implicit format. So a lot of the things you can change at runtime. So you can change paths at runtime, you can change colors at runtime, you can remask certain layers. So that's just an example of Bevy Velo. Here's an example of a Lottie file in general. This isn't running on Bevy Velo, but Bevy Velo has direct support for Lottie as well. So we just saw I was running a Lottie file in Bevy Velo. It was the calendar. Here's another Lottie example. This comes directly from Google Fonts, the same team that's making Velo. There's open source Lottie files for pretty much any emoji. So all of these will render in Bevy Velo as well, in case you were ever curious and wanted to run it yourself. Close out of those. And then here's an example of a game that I built with the help of another colleague. His name is Sebastian Hamill. And this is an example of an actual Bevy game being used with Bevy Velo under the hood. So we can zoom in anywhere and see there's no loss of resolution. I can zoom in on anything from the tiger's eye to his whiskers and really never see a pixel. So all that is just working natively and in the browser. Can control the pieces of bacon, and it's kind of like a little game of Pong. It's not too intricate, but it's a good example of just Bevy Velo in actual use case. So what's cool also about this is that vector graphics, since they are implicit in the actual image, you can take the underlying paths and the data structure in the image and convert that to like physics colliders. So in this case, the colliders are not being added manually, whereas in most other game pipelines, you're going to want to add your own colliders. In this case, the colliders are being automated because it takes the SVG of the egg, it derives a convex hull around the egg, and then uses that as a physics boundary. So lots of cool different ways to uniquely use vector graphics that could represent an overall positive delta in game development like that. So tons of cool ways to go. We also have integrations and people using Bevy Velo in the wild. So a really good example I want to showcase is there's this really cool library called Bevy Motion GFX, which they're using Bevy Velo to render these really neat, cool vector graphics. So they have integration with types, which for those who are familiar with LaTeX, it's kind of the same thing. It's a replacement to LaTeX. So you can do these nice rich animations for things like YouTube videos and really make some visual appealing looking things. There's also the game I just showed you, which is called Vector Graphic Pong. or Vong for short. There's a spline editor that I've seen been done, and then also I have a game studio that we're developing a little game called Woot Newts, which I'm not ready to share that today, but it's in development. We use Bevy Velo for pretty much the entire stack. So that's basically all I had for demos. The usage of Bevy Velo is actually really simple. So if you're curious, how do I render an SVG or a Lottie? We have tons of examples. So if I want to know how do I render an SVG, which is a pretty common use case, there's a very simple, just 20-line example. You have to spawn your camera, and then you just spawn a Velo asset bundle where you use asset server.load, and then you provided an SVG. And it really is that simple. If you wanted to do the same for a Lottie animation, it's likewise just as simple. And if you wanted to experiment with scenes, you could do that. We also have an example with Scene UI. So if you wanted to use Velo's native scenes for things like checkboxes and things for UI, that's in the works. Or you could do the same thing that we did in the Bevy Velo demo, which is use an actual Lottie file kind of as a UI component. So you can see how this could maybe be extended to be a button where you hover. So lots of opportunities, not just if you wanted to write code, but if you wanted a designer to design the UI and buttons and then add state machine transitions like on mouse enter, on mouse click, and hook that up programmatically. And I think we have a lot in the works for that. That's really cool and coming out. But yeah, that's the end of the actual presentation for Bevy Velo, and I'm able to take questions.
Thanks, Spencer. Amazing stuff. Now I want to throw it in my project and give it a try. Yeah, we have a bunch of questions. Let's see. So what's Google's game plan with Velo? Will they power Chrome's SVG at some point?
That's a really interesting
if you know
question.
anything about that.
Yeah, so I do not work for Google. So there's sometimes a lot of questions about whether or not Velo is a Linebender thing or if it's a Google thing. And Linebender is this open source organization that works on things like Velo and Velo SVG and Velato and Bevy Velo. So I'm in the Linebender organization. But Google is specifically funding Velo. And I think it would be a great thing if the work from Velo gets integrated into like Skia, for example. That's your browser's vector graphics engine. So that way, things like slow loading PDFs just go away for all users of web browsers. I think that is a great example of how Velo particularly could help out a lot of people and start getting integrated to technology that millions and billions of people are using. However, I don't know what Google's plans are, and I think a question like that could go to the Linebender Zulip chat where you ask the Google employees directly.
Yep, noted. How does Bevy Velo play with Bevy UI? I guess in terms of clickability and stuff like that. Is that will that work out of the box?
Yeah, so you can attach scenes to nodes, and you can attach images to nodes, and they will take up the bounding box of the UI node. So it will just automatically scale to UI nodes. Since vector graphics, you can scale them in X and Y, and you can do all these transformations to them. It should just work exactly as you expect. And we have a great example of that. It's called the Scene UI example, where it uses a UI node and then draws a check mark over that. And there's hover and click logic to dig into if you're interested in how to use Velo for UI.
Okay, so that would also be an example then if I wanted it to be like per pixel. I mean, at the end, it's still a matter of pixels, pixel perfect hovering and clicking. If there's like roundings around the edges and stuff, is that also part of this example? Because otherwise, it will still basically just recognize the whole rectangular size that you mentioned of the node as the hover area of the thing, right? If I wanted, if I wanted to ask Velo, hey, is my cursor really in this SVG or not? Is that provided?
Yes. So that is provided as part of some of the new experimental .lottie work that's going on. However, hooking up hover events and things out of the box for scenes specifically, that is something you'd have to implement yourself, and there is an example of that in the scene UI. However, you should not see any jagged edges or pixels using Bevy Velo at any time. That would be considered a bug. We do take the pixel density of your like monitor and example, and we do the appropriate resolution scaling. So just to make sure.
Gotcha. Okay, that's cool. And the next question is, I've not used Lottie, but does it have a what you see is what you get editor for these animations? Because that looks like a powerful authoring way then for content in Bevy, I guess.
That's a really good example, or that's a really good question. So there are new tools that are coming out specifically to edit Lotties. I would really point to lottielab.com. They are a really rich, powerful Lottie editor. I'm not sponsored by them to say that. Everything I've been doing to make Lottie animations or test out with Lotties, I've basically used their tool. But I think more players are coming in the commercial atmosphere for this. So there's lottielab.com, there's phase.com, which is coming out with a Lottie tool. There's lottiefiles.com, which is coming out with a Lottie editor, and but it's a very quickly moving space. Lottie files, the actual format is relatively new, I would say within the last 5 years. So when I started to research vector graphics back in 2019, or even earlier, for thesis work, Lottie didn't exist. So this is still kind of new. So there's new tools that work and that you can use right now, and some of them are free, like lottielab.com.
That sounds really cool. I mean, that's at least covering some parts of the non-existent editor that might people look for, right? And let you author some of the animations and graphics in a Bevy game. Cool. Can you make a website, not a game, with Bevy Velo, or integrate it with Leptos or Dioxys?
That's a really good question. So I haven't used Leptos or Dioxys. I've used U before. And yes, I'm certainly confident that you could do that. However, you'd be kind of constrained to having Bevy run in a canvas. So if you're looking for native, put the SVG and control an SVG on the DOM, that's a different story. That's not going to be possible with Bevy Velo. But if you want to render within a canvas and then embed that in your website, that should be totally doable. Everything in Bevy Velo is able to compile and run for native web, and it should also work for Android. iOS is a little untested. I don't think that's an official supported target of Velo, but it's not something that wouldn't work. It's just that given that it's being championed by Google, it's something where Android is going to be the first player to get official support there. Not to say that there's any barriers or roadblocks, though.
No, makes sense. Okay. So what's the next one? We had that one. When web GPU in all browsers? Well, that's again not really to the topic, but I guess there is a point, right? It will not work in, I guess, Safari right now. Or what about Firefox? I'm not sure about web GPU in Firefox.
Also a great question. So web GPU has been one of those slowly stabilizing technologies. When I first started doing these experiments, none of the browsers had stable web GPU support. There was tons of bugs. And slowly Chrome has stable web GPU support now. Firefox, you can get it working with a flag in the nightly version of Firefox. And Safari has technical preview for web GPU. But I think all in all, right now, as of, I don't know when you're going to watch this recording, but as of July 2024, Chromium-based browsers are the only browsers that have stable web GPU support, which accounts for about 77% of current worldwide browser usage. So the remaining amount of browsers should get supplemented by CPU fallback that Velo is implementing. So instead of needing web GPU compute shader support, you can fall back to CPU rendering. That being said, that's not going to be a real good.
That's not going to be great.
Fallback if you're looking for games. If you're looking just to render SVGs and lotties a few times a second, or just simply rendering, like making an SVG renderer or a lottie renderer, that should be fine with CPU fallback. But I don't know how performant the CPU fallback will be. It's not something I'm looking into, and it's not something that's complete either within Velo, but it is being planned. I would say, based off previous research I did in my thesis, which is a few years old now, back then CPU bound vector graphic rendering is on an order of magnitudes slower than compute shader rendering. So that is to say, compute-centric rendering should be the state of the art now. It is a massive technology leap compared to how vector graphics used to be rendered. I would even venture as to say it's about 10 times quicker. Mileage will vary. That's a very rough estimate, but I would stand behind that.
Yeah. Okay. There's a few more questions that popped in. So if we still have a few minutes of your time, how does rendering SVGs compare to rendering sprites or images in terms of performance? That's an interesting one.
Yeah, I can't really compare those two meaningfully. When you render a sprite, it's going to use the standard Bevy rendering pipeline. And when you render with Bevy Velo, what's going to happen is, for one, you're going to load up the asset with the asset server. That's going to parse the SVG or parse the lottie, and then it's going to spin up an intermediate renderer. So for something like a lottie file, it's going to translate the SVG in memory to a Velato renderer, and then every frame you're going to request a new frame, and that encoding is very cheap and easy to send to the GPU. So there's not a lot of real performance overhead with rendering. So here's a good example. I have a good image for you. So here's 100 peacocks all being rendered in an animation all at once. So and all of these peacocks have hundreds of paths. So this is something that I think there's a lot of potential with the current pipeline. It's very performant. I just think your perception of how you're going to measure things is going to change. So instead of thinking of like triangles per second, you're going to think more in terms of like curves per second, or you're going to have certain limitations on web, or you're going to consider your platform and the limitations it has. You shouldn't really be bottlenecked on any specific thing. Like I said, there's no performance landmines with Velo.
Yeah, and it's really hard to make it like a meaningful comparison, like an image that you render 1,000,000 times versus a SVG that you render 1,000,000 times. That's really hard to compare.
Yeah.
The last one is a bit cheeky. Will Bevy compete with 3JS?
That's a question about Bevy. So my opinions on Bevy are very good. I mean, I would say that Bevy is the most ripe game engine right now in the Rust ecosystem, and I want to continue contributing to the Bevy space. So I think any good engineer is going to use the right tool for the job. So if you have a very simple task and whatever work you need to do for rendering a 3D model, maybe 3JS is the best solution for you. Maybe you're better off just finding an open source model viewer that's just ready to render your model. But in terms of a game engine that's written in Rust, I think Bevy's the most promising right now, especially because of its selling points being code first and having an open source foundation, and it seems to be done very responsibly. So I'm very happy with the direction Bevy's going in, and happy to see Bevy Velo be a part of that.
That couldn't have been a better ending to this conversation, I would say. Thank you so much, Spencer. And it was a great presentation, super informative. And I'm really excited to give it a try, especially looking at these authoring opportunities with Lottie. That's really exciting. So keep up the great work. I'm definitely going to follow this closely. Thank you.
All right. Thank you so much. It's a pleasure to be a part.
So that's already the end of our 5th meetup. Let's quickly pull up the ending slide. I'm thanking so greatly to the 2 speakers. It's always great to talk to potential speakers and figure out, it's always exciting to find dates that work for everyone and make sure that we get a good lineup. So I'm asking you in the audience as well. Is there anyone that you would like to see on stage next time? Is there any topic that you're interested in that I should try to dig up someone to talk about? And if you have a topic yourself that you would like to present, please reach out to me. I'm always looking for new, interesting content. And other than that, I would say thank you so much for joining today. And keep an eye on this RustUnit.com YouTube channel for the recordings that are going to come up over the next few weeks once I have time. And join us on the bevygamedev.com meetup page. And also, I mentioned Rust Unit. We are hiring. If you're interested in combining Rust with game development, please reach out to me. And yeah, thank you so much. I'm closing this stream for now, and see you next time.